Right. So this is me. I'm going to stall for a minute. Maybe more people will come. So this is me, Stanislaw Raczynski. I'm involved in multiple ventures, but here today I represent mostly PicTech. PicTech is a research, non-public research foundation. We focus on performing research for the benefit of business and industry. And the work I'm going to talk about today is a collaboration between the PicTech and Inelion. Inelion is a electric vehicle charging company from Gdańsk. So the context is smart energy because of the collaboration. Let me. Right. So I'm a bit worried about this presentation because there's a lot of things that are not the topics of this conference. So that one thing is that there's a lot of things that I need to squeeze into this 30-minute presentation. I'm going to talk about all sorts of things, including electromobility, so electric vehicles, smart grid, smart energy, smart charging, IoT, data science, machine learning, distributed ledger technologies. There's a lot of things in this presentation. So I'm a bit worried that it's going to be a bit chaotic. Also, what I'm going to talk about is mostly not really production ready. It's not something you can just go home and use in your project. This is still, in many areas, a work in progress. This is still early beta or even research phase. So I'm going, well, so I'm just worried that this presentation will be difficult for you to digest. So I'm going to do a few things to help you out with that. So I'm going to give you an executive summary, brief summary of what I'm going to do, what I'm going to talk about today. And then I'm going to ask you a few questions, and then based on that I'm going to improvise a bit during my presentation, maybe focus on some things more than the others. Right. So, in short, I'm going to try to convince you that blockchain is just an elaborate it's just an elaborate data structure. It's pretty much a distributed database. It's a thing for storing data, and this is how I want you to look at it today. And the other thing that I'm going to try to convince you about is that we are, well, we need a data sharing solution. So far we've been hoarding data in the corporations. We've been giving away our data for free on Facebook, but we don't really have really good, scalable, secure, private-centered data sharing solutions. And blockchain is the way to actually achieve that, and to achieve sharing economy of data. Like I said, I'm going to improvise based on a few things I'm going to ask you about now. So, do any of you, what's your knowledge about blockchain? Do you know how blockchain actually works? Like, how many of you know how blockchain works? Like, oh, not many. Well, this is good. And how many of you think blockchain is evil? Like blockchain, cryptocurrencies. How many of you think this is like these are overhyped, like useless, evil things? Well, okay. Well, be honest. I want you to believe that, because I'm going to try and convince you otherwise. That the blockchain is not evil. Blockchain is actually very good for us. It just misunderstood. Okay. And the reason I ask is that most people believe that. Most people think distributed ledger technologies. Well, distributed ledger technologies is just a nice euphemism for blockchain. It is a bit broader than blockchain, but basically it's used as a euphemism because people think blockchain is bad. So instead, we now prefer to say distributed ledger technologies. I'm sure you've seen the this plot. This is a hype cycle. This is by far my favorite plot. This shows hype cycle of every new technology goes through. So at first people are excited about new things. They get overexcited. They get to the peak of inflated expectations. They think, wow, this new thing. There's new thing. There's deep neural networks. They're going to solve all our problems. There's blockchain. Blockchain is solving everything. There's a common pattern. Like we get excited, and then we realize that this is actually not what we wanted. Like we don't see any practical solutions. We don't see any practical problems being solved by the new technology. So we go down to the trough of disillusionment, where we think that this technology is basically useless. And this is where we are right now with both cryptocurrencies and distributed ledger technologies. We all think they were overhyped, and there's a very bad rap connected to these technologies. But we're slowly climbing the slope of enlightenment towards the plateau of productivity. So I really believe that DLTs, distributed ledger technologies, have way more applications that they are much more useful than we give them credit for. Distributed ledger technologies, since you don't seem to know much about that, based on the two hands that went up when I asked you about that. So it's not like, it's not just Bitcoin, right? Bitcoin was the first generation of distributed ledgers. Bitcoin is only useful for sending value, exchanging value, making transactions, and that's it. Like there's a distributed storage of data, but this data is only related to transactions and value that we own. But this was the first generation of DLTs. Then came the second generation with the Turing abstraction. So actually, Ethereum was one of the first to do that. Instead of just exchanging value, we can now store data on blockchain, and even more, we can perform computations on the data. So we have we can use smart contracts we can execute smart contracts on the blockchain to transform the data and save the results on the blockchain. So that's the second generation of DLTs. But today we are more interested in the third generation of the distributed ledger technologies, which came with the invention of distributed directed acyclic graphs, DAGs, which introduced scalability and lightweightedness to the blockchain world, so that we are able to actually include even mobile and embedded devices. We can plug them directly into the blockchain. So not only can we store data on the blockchain, we can process the data, but now we can also connect IoT devices, mobile devices, embedded devices to the blockchain, and they can feed data directly to blockchain. There's also a fourth generation of DLTs, but I'm not going to go into that. And this is actually something that is happening right now. It's pretty fresh. Like, I think the quorum-based computing is something that was announced last month on the Iota platform. Right, so I'm going to try to convince you that blockchain is basically a data structure for storing data. Like we can store data efficiently, securely, privately on blockchain. So you are all interested in data, right? That's why you came to this conference. And so there's been a few projects, there's been a few ideas people tried to implement to use blockchain for storing data, for sharing data. Like for example, there's Synapse AI was the first economy of data, economy of machine learning. So people could actually share the data sets, they could share trained models, and they could exchange tokens. They could exchange currency, like for the data and models. So we could actually create a data set and then earn money from people using the data set, or train a model, train a great model based on someone else's data, buy the data and then sell the model and still earn something. Like they have they have a utility token called SYN. Right, so this is the general idea people were trying to explore. This is a similar concept. Like you have the data plane when you store data in a distributed hash table. Like, well, so essentially it's just torrent with cryptocurrency. So pretty evil. Right. So then you had this new project, this Genie.io. But actually, like I want you to forget those. This is actually the reason why some of you, at least, think that blockchain is evil. 81%, according to a recent study, 81% of the projects of the ICOs, because that's the way people usually get money for projects in the blockchain world. 81% of those projects were scams, and actually, like Genie.io is one of them. Like it's a really great concept. Like it's decentralized machine learning. You can exploit the network behind blockchain to train models, like distributed computing for machine learning. This is pretty exciting. But once you look at the white paper, it's actually like 20 pages of complete nonsense. So that's the reason you probably think these are evil. And like I said, Genie.io is here, is a scam. And the first project, Synapse AI, I told you about, it's a failed project. It stopped half a year ago. They didn't raise the money, they just stopped doing that. But, like, please, like, I'm only showing this to you to explain why the reason behind the bad reputation of blockchain. But actually, there's a lot of good projects, and Iota is the one I'm going to talk about. Iota is different. It's definitely not a scam. There's a foundation in Germany that actively develops Iota. It's very and it's a disruptive technology. So I don't have any. Like, has any of you heard of Iota before? Okay, well. So I'll have to explain some things then. Iota is a truly disruptive technology. So Iota is not actually blockchain. That's why that's another reason why we say distributed ledger technologies, because not all technologies are based on blockchains. Blockchains has many limitations that, like, we could not efficiently store data on blockchains. This is really difficult because of the limited scalability of blockchains. But Iota is different. It's not based on blockchains. We don't put the data and the transactions and everything we want to store in blocks which are being signed by miners somewhere. There are no miners in Iota. Mining is distributed among all nodes of the network. So there are no miners. It's instead of based on blocks, of chain of blocks, it is based on directed acyclic graphs, which in this case means that everything we want to put on the blockchain, every transaction, and transaction can be exchange of value, like in Bitcoin, but it can also be exchange of data, or both at the same time. So every transaction, in order to be added to the, it's called tangle in Iota terminology. If you want to store something, a transaction on the tangle, we need to first verify 2 previous transactions. Like we need to perform a small proof of work. We need to find, we need to calculate millions of hashes and find the one that actually verifies the 2 previous transactions. So, but because of that, because every transaction needs to validate, confirm 2 previous transactions, this is a much more scalable solution. It's actually, theoretically, it's, well, infinitely scalable. That's the word some people are using. Practically, it is not, but in theory, we can, like we have no limitations about what we store on the tangle, and actually, the more transactions we do, the higher the capacity of the network is. Like because the more nodes, the more transactions, the higher capacity because of the 2 transactions that we confirm. And because this is important because there's no mining, we don't have to pay transaction fees that will go to the miners. We don't, to store anything on the tangle, we don't have any fee. We just participate in the network. We do the proof of work. We participate actively in the network, and because of that, we can make transactions without any fees. So we can have like nano payments. So, for example, like we can buy a single row of data from someone for a millionth of a dollar, $1,000,000. Like this would not be possible in any other scenario other than Iota. Right. So, and the data that is stored on Tangle is immutable. Once it's confirmed, there's no way this information can change. So this is pretty reliable. The storage is reliable. It's authenticated. We have a guarantee that the data came from the source that we expected to came from. It's permissioned. So even though the network is public, it doesn't mean that we can access any data that is being stored on the Tangle. We need to have keys to access the data. It is real time. We can store real-time data on the Tangle, and it's fine grade. Like I said, we can have nano payments, microtransactions. Yeah. So I spent a lot of time on this slide. I'm going to have to go quicker through the other things, but so Iota is a perfect way for storing data, and it's, well, as the name suggests, it's perfect for IoT, Internet of Things. So it's perfect for things like automotive and smart energy, and this is something we focus on. And actually, this is just an example. This is data stored on the Tangle from a vehicle moving through a city. Like there's a stream of data recorded by the vehicle. It's all stored on the blockchain. Sorry, I'll just skip that because I'm running out of time. So my point here is that Iota is essentially an engine, it's a database engine. It's a data backend system that provides us with data transmission, integrity, persistence, security, privacy, and trust. We have all that from the Tangle. We can store data in a very efficient and secure way. And then we can build also all sorts of things on top of that. It's actually very common to in the blockchain, in the DLT world, to create stacks, like protocol stacks, but we have the layer 1, which is Iota, and on top of that we build more advanced solutions, and on top of those we build even more advanced solutions. So 2 examples of layer 2 solutions on top of Iota: masked authenticated messaging, Cubic, which allows smart contracts, quorum-based computing, but I'm not going to talk about that. Masked authenticated messaging is something that we use in our project. So, like I said, this is not really science fiction. This is something we are working on right now. It's not production ready yet, and our project is a long-term project. We are thinking we're going to have something marketable. We're going to have a product in 3 years. But these things you can already use now. Like masked authenticated messaging. You have multiple implementations you can use even today. And masked authenticated messaging is essentially a linked list. It's a data structure for storing streams of data on the Tangle. So you have a string of messages, and each message points you to the address of the next message. So we can, when you have the root message, you can track the chain of messages for as long as you want, or until the device stops transmitting data. Well, this is perfect for IoT. This is perfect for what we're doing, which is electric vehicle charging. And this is efficient too, because we don't, like, each message does not have to be confirmed by the network. Only the first one needs to be confirmed by the network. So we also use something called flash channels, which are communication channels off-chain. So they are not, the data is not transmitted through the chain. We don't save the data on the chain. We open a channel, like for example, between a electric vehicle charging station and a vehicle. And as long as the channel is open, we can exchange tokens between the two devices. So for example, every 100 watt hours we're paying for what we for the electricity that we used so far. This is a typical scenario for any on-demand service. Like, we can imagine this can be used for, I don't know, platform as a service or whatever. In the few minutes I have left, I'll try to tell you that about what we're doing in this project, in the collaboration. This is real-time use cases, and this is something we think is going to be ready and useful in 3 years. And we are basing on things like this, not production ready, but things that are already implemented, so we can use them. Like, there's a lot of things in Iota which are planned and not implemented, but these are all implemented. So we have 2 use cases which we investigate. One is Iota-based public electric vehicle supply equipment. EVSE is basically car charger. So a publicly available one, and a private one within a microgrid. So a microgrid is an energy grid which is isolated from the power, from the power distribution network. I'm not sure if I'll have time to talk about that, but so let's look at the first use case. This is more or less the architecture of the system that we are developing. So we have chargers. Chargers use the masked authenticated messages as a way to store streams of data that include temperature, current, voltage, battery status, usage, all sorts of data on the Tangle. And this data can be accessible from any Iota node. It can be a mobile phone, for example. It can be a browser. So you can, for example, access your charging data. You can see the progress of the charging, of what is the what is the charge of the battery in your car, which is available thanks to this 15.1.1.1.8 protocol. This is a TCP/IP based protocol for communicating between chargers and electric vehicles. Right, so you have Tangle that is used to store data, charging data, and you can access the data. And actually, like, no one else can access the data unless they get the root message address and the key. And we can imagine that like this centralized back office, this is a database that stores these things like the location of the charger, the root and the key. Like we can sell this data. We can we can use paper API. Someone else can pay to get the measurements from your charging. Of course, it would have to be anonymized. But the point is that we can share our measurement data with anyone very easily because it's already stored in a publicly accessible place. All you need is a key, which you can get if you ask or if you pay for the key, depending on the scenario. So, of course, we could, instead of using the Tangle, like Tangle is also used to pay for the for the charging, right? So we come with our mobile phone with it has an Iota wallet installed on it, and we directly pay the charger, and charger starts giving us electricity, like starts charging. This is one benefit of Iota, but storing the data, of course we could do that in this database, right? Like we can do that. What's the benefits of putting it on the Tangle? Well, so the benefit is in data sharing. That's the thing I'm trying to convince you about. Well, this is a value chain. I'm sorry, it's in Polish, but it's not really important. This is a value chain of all the actors involved in a charging process. So you need all sorts of service providers to perform charging. And typically, it's only the CPO, the charge point operator, that stores all the data. And sharing the data between such different actors is very difficult. So we can imagine that charging data can be useful, for example, to the distribution network operator, so the power grid company, because they could efficiently perform grid load balancing, for example. They could access data from the chargers. Car chargers, electric vehicle chargers, is actually a huge stress on the power grid. If you connect, like someone calculated that if you go to France and replace all vehicles with electric vehicles and then plug them into the grid, the total power required to charge them would be 3 times higher than the maximum available power, like maximum output of all power stations in France combined. So we don't have so many electric vehicles yet, but this is a huge strain on the grid. But actually, it's a huge strain, but also an opportunity. We can buy electricity back from the electric vehicles in a vehicle-to-grid scheme. But to do that, the network operator needs to have access to data, and we can provide that using Tangle, for example. We can imagine, for example, the company that CPO is just the owner of the charger. There's probably another company that services the chargers, and they would be interested in the data as well, because they would probably want to perform some smart maintenance, predictive maintenance, for example. Like predictive maintenance is the maintenance when you predict failures based on measurements from a device. So, like sharing this data and allowing people to access, granting them access, is obviously beneficial, and the very efficient way to do that is via Tangle. And this is, like I said, this is not production, but people are looking into that, and people are building prototypes. This is not our prototype. We don't have a prototype yet, but this is a prototype from Netherlands. This is a charger that actually uses Iota for storing measurement data and for payments. This is another nice example. This is a hardware accelerator for Iota, which allows us to run a full node on a Raspberry Pi. Because we still need to perform some proof of work. So we need to contribute to the network, and we already have hardware accelerators to do that. Right, so I'm sorry, but I'm going to skip the second use case, which was a microgrid. It's a very similar, it's a different scenario, but the similar message. Sharing data is useful for everyone, and we can do that using Tangle. So I'm out of time, so just to conclude, Iota, well, I hope I convinced you at least a bit that Iota is a solution for storing data. It's still being developed but it's the first true data sharing economy solution. So we can store data, we can exchange data, we can pay for data, we can have a sharing economy of data on Iota. But it's probably not the first, the last one. Like some other solutions will arise, like Hashgraph is a commercial alternative to Iota. And there's still some issues with Iota. So I said before that Iota is infinitely scalable, which is actually not true. So far, the stress tests, the most stressful stress test performed on Iota measured only 1,000 transactions per second on the entire network. So we're like. I'm sure you're thinking, well, this is not huge, right? Like we can do better with solutions we already have. But and we actually don't know what's going to happen if we go even further. This is still research, right? So just to summarize, well, everything is decentralizing. The energy is decentralizing. Well, I skipped the microgrid example, but we have distributed energy resources now. We have distributed decentralized energy generation. We have distributed data production, data creation, like with IoT. Data comes from multiple distributed sources. We have distributed data consumption because we have multiple actors, multiple people, multiple interested parties in the data that we create, and we should have decentralized storage for the data as well. The data economy, the decentralized sharing, the decentralized data storage and data economy, plus, you know, there's a huge trend in machine learning now to go embedded. We're going from the cloud to the edge. We are running our models on mobile phones, on embedded devices. So if we combine these, what we get is the ambient intelligence that I referred to in the title. Right. So this is it. Thank you. Sorry. I don't think we have time for questions, but I would really love to talk to you some more. I will be around until the end of the conference. Thank you.